We all know Buddha was born in Lumbini, Nepal. But let's step away from pure emotion for a moment and explore something even more fascinating. What did Nepal actually look like 2,600 years ago? What was the climate like? The geology? How did powerful tectonic forces shape the very land where Siddhartha grew up? And what kind of ecosystem thrived in the Terai long before modern roads, borders, and settlements? This is a purely scientific reconstruction based on geology, paleoclimate data, archaeology, and the geography of ancient South Asia. Let's travel back in time to the year 563 BCE. Long before Buddha and long before humans even walked these lands, Nepal's landscape was already being forged by the world's most dramatic geological event, the collision of the Indian plate with the Eurasian plate. By the time of Buddha, this process was well underway. The Himalayas had already risen to near modern elevations. The main central thrust, a massive fault line, was extremely active, constantly uplifting the hills and mountains. Erosion from these young, towering Himalayas created vast deposits of rock and sediment, which formed the Siddhartha hills that we see today. This is crucial because the region where Buddha was born, Lumbini and Kapilvastu, sits right at the foot of this massive, dynamic tectonic system. Around 563 BCE, the Terai region was actually expanding, created by millions of tons of fresh sediment carried down from the Himalayas by powerful rivers. The landscape was flatter, younger, and far more dynamic than it is today. Earthquake cycles, a constant feature of this region, were active even then, contributing to major river shifts and shaping the patterns of the forests. So when Siddhartha was born, he entered a world defined by ongoing, powerful geological transformation. Now, let's picture the ancient ecosystem of the Terai. Today, we think of the Terai as hot, humid, and filled with farms and settlements. But 2,600 years ago, the scene was completely different. Scientific studies of ancient pollen deposits, sediment cores, and fossilized plant remains paint a vivid picture. The Terai was far wetter than it is now. In fact, the monsoon was an incredible 25 to 30% stronger. The ground was covered with dense, towering sal forests, mixed with vast wetlands and sprawling floodplains. This incredible ecosystem was teeming with wildlife. Imagine Asian elephants, one-horned rhinoceros, gaur or wild cattle, swamp deer, and Bengal tigers roaming freely. The air would have been filled with the sounds of hundreds of bird species, and the wetlands would have been home to countless marshland reptiles. If you were to walk through Kapilvastu during Buddha's childhood, you would hear elephants calling in the distance, see rhinos grazing near wetlands, and step through forests thick with sal, acacia, fig, mango, and jamun trees. This wasn't a dry, dusty plain. It was one of the richest, most vibrant ecosystems in all of ancient South Asia. Let's dive even deeper into the climate of 563 BCE using the fascinating field of paleoclimate science. Climate reconstructions based on evidence like lake sediments from the Indo-Gangetic Plain, stalagmites from Himalayan caves, and isotopic oxygen data all point to the same conclusions. Around the time of Buddha's birth, the South Asian monsoon was significantly stronger and more reliable. This meant annual rainfall was higher, winters were milder, and the region experienced much longer wet seasons. So what did this mean for the land? Well, forest cover extended much further than it does today. Rivers like Terai and Bandanga carried far more water, making them bigger and more powerful. Wetlands were common, even near city centers, and agricultural productivity was incredibly high, thanks to the fertile alluvial soil deposited by the rivers every year. In other words, Siddhartha grew up in a land shaped by powerful monsoons and an abundance of fresh water, a much greener and wetter world than the Terai we see now. Most people imagine Kapilvastu, the capital of the Shakya kingdom, as a small, simple village. But archaeological surveys tell a completely different story. The ancient capital, located at Terai, reveals a sophisticated city. It was a walled city with gates to the north, south, east, and west. The streets were laid out in a geometric grid, showing clear signs of urban planning. Excavations have uncovered complex water management systems, pottery kilns, metal workshop areas, religious structures, and administrative buildings. All of this points to a highly organized society with skilled craftsmanship and connections to long-distance trade. What's really interesting is how the city was geographically positioned. It sat on a slightly elevated terrace formed by ancient river deposits. This strategic location protected it from the worst of the monsoon floods, while giving it access to major trade routes, connecting it to the greater Gangetic Plain. It also benefited from the incredibly fertile soils and nearby forests for resources. The Shakya kingdom didn't emerge randomly. It flourished because the geography itself supported and sustained urban growth. Rivers shaped civilizations, and in 563 BCE, the river systems of the Terai were very different. Hydrological reconstructions show that the Rohini River, which was a point of contention between the Shakyas and the Kolyas, was much wider and deeper than it is today. Seasonal flooding was a regular event, but it was also a blessing, as it created vast, fertile floodplains every single year. The Banganga and other river circuits were used to support extensive irrigation for agriculture. And as we've seen, wetlands extended far beyond what we see today, creating a unique landscape. These rivers were the lifelines of the kingdom. They supported agriculture, especially rice cultivation. They acted as highways for trade routes, connecting Kapilvastu to other major centers. They served as wildlife corridors, sustaining the rich biodiversity of the region. And they provided the water needed for settlements to thrive along the Shakya-Kolya border. Siddhartha likely grew up seeing a bustling river culture, fishermen casting their nets, ferrymen carrying people across the water, boat traders moving goods, and vast rice paddies fed by these dynamic river systems. So let's reconstruct what daily life might have been like in Kapilvastu based on scientific and archaeological evidence. When it comes to housing, people lived in homes with sturdy brick foundations, timber frames, and thatched roofs. These homes often had courtyards, granaries for storing food, and wells for fresh water. And what about food? Isotopic studies of ancient grains found at the site show the presence of rice, barley, wheat, lentils, sesame, and mustard. People also enjoyed melons, mangoes, and wild berries from the surrounding forests. In terms of technology, this was the Iron Age. People used iron tools for farming and construction, wore copper ornaments, and used beautifully crafted wheel-thrown pottery. There's evidence of pottery workshops, textile production, and advanced carpentry. Kapilvastu was not an isolated kingdom. It was connected to powerful trade networks that reached the Gangetic Basin, to cities like Shravadasti and Vaishali, and perhaps even to early Iranian trade routes. This was not a simple rural village. It was a scientifically advanced and well-connected urban center for its era. Now, let's use all this science to reimagine the famous scene of Buddha's birth. Queen Maya was traveling from her home in Kapilvastu to her parents' home in Devadaha, both of which were established city-states. This travel route would have passed through the dense south forests and river-fed wetlands we've described. Based on botanical and archaeological reconstructions, we can picture the scene. Towering sal trees formed a dense canopy overhead. The ground was covered with ferns, reeds, and perhaps even blue-flowered herbs. The air would have been alive with the sounds of insects and birds, and freshwater pools would have been found near clearings used as rest stops. The birth likely happened in a shaded forest rest point, which were common along ancient travel routes. This was a natural, serene, An ecologically rich environment, exactly what the scientific data suggests for that time and place. Here's one final scientific and historical fact that is often overlooked. The region we know today as Nepal shows a continuous cultural presence for thousands of years. This doesn't mean that modern borders are ancient, but culturally and geographically, the Himalayan Terai zone has maintained a continuous settlement, continuous language families, continuous political systems, and a continuous geographic identity. Unlike many regions that fragmented or were completely absorbed by others, Nepal's cultural geography has remained remarkably stable. This gives real scientific weight to the statement that Nepal is one of the oldest continuous civilizations in South Asia. So, what have we learned on our scientific journey back in time? When Buddha was born, Nepal was geologically young and tectonically active. The Terai was a lush, subtropical ecosystem far wetter and greener than today. The monsoons were stronger and the rivers were fuller. Kapilvastu was a well-organized, planned city-state, not a simple village. Daily life was supported by fertile floodplains and abundant forest resources. And perhaps most importantly, Nepal was already a continuous cultural region with deep historical roots. The scientific reconstruction doesn't take away from the spiritual story. It enhances it, showing us that Siddhartha's world was a real, tangible place, deeply shaped by the powerful forces of geography, geology, and climate. And that world existed right here in ancient Nepal. Thanks for watching. If you found this journey interesting, don't forget to like and subscribe for more deep dives into history and science.